All right, we're going to look at two problems, 25 and 26 in section 5.3. Both of them instruct us to evaluate the indefinite integral, and they're related. So 25 is this one. Again, your numbers might be slightly different than this, but the idea will still be the same. Well, notice this is 15e to the 7x. So we talked about this in class. We know the derivative of e to the x is e to the x. So the integral of e to the x is e to the x plus c. All right, so that's easy enough. But the derivative of e to the 7x is by the chain rule, right? Because you have a composition of functions. The outer function is e to the u. The inner function u is 7x. So the derivative is by the chain rule, right? The derivative of the outer function is e to the u, e to the 7x, times the derivative of u with respect to x. What's the derivative of 7x? With respect to x, it is 7. So 7 times e to the 7x is what we get. So notice the integral of e to the 7x dx just can't be e to the 7x. What do I need to do? I need this 1/7 factor in front. So now when I take the derivative of e to the 7x and get this, the 1/7 times the 7 will give me the coefficient of 1. So this is the antiderivative. And so our original problem now I can do 15 is a constant multiple, pull it out. The antiderivative of e to the 7x, as we just said, is 1/7 e to the 7x. And I can simplify that as 15/7 e to the 7x. Don't forget your plus c. So in general, we have basically this rule we developed in class, right? And we're going to get more into undoing the chain rule with the substitution method soon. But this is basically a simple undoing of a chain rule, right? E to the kx dx is 1 over k times e to the kx plus c. All right, 26 is similar to this one. It's, of course, first of all, notice the variable is now t, not x, so your answer should be in terms of t. E to the 8t minus 16 dt. Well, it doesn't quite look like this. Of course, this is kx, but it's not kt. It's 8t, but there's this minus 16. How do we handle that? Well, just note that e to the 8t minus 16 is e to the 8t times e to the negative 16, right? When we multiply like bases, we will add their exponents and get back right here. But notice important, the e to the negative 16, there's no t. It's a constant. It's a constant multiple. So in this problem, I can rewrite the integrand, that function we're integrating this way, and then just pull that constant multiple out in front. And now what? I have e to the 8t, which I can use this rule we developed here. Of course, our variable is t now, and the value of k is 8. So this will be 1/8 e to the 8t. And then, of course, multiplying by our constant multiple. To clean it up, I can remultiply, and when I multiply e to the negative 16 times e to the 8t, we know what we get back to the original function there. And so here is my final result, finding the antiderivative of this. Okay, hope this is helpful.